Hello everyone, I am Emiliano Gonzalez, and this is my final presentation about how do annual temperature phenomena impact on economic losses over the years in France. I am from Tec de Monterrey, Campus Monterrey. First of all, we have to identify our variables, being the independent variables, the x-axis that I will later explain, annual maximum temperature, annual minimum temperature, this in Celsius degrees, annual maximum rainfall in milliliters, annual maximum wind speed in meters per second, and annual maximum sunshine hours in hours. The dependent variable is the total economic losses in billion of euros, and the other variables that will help to perform a data analysis is the years of the registered data. First of all, where did I get this data? First, the climate data, I get it from the European Climate Assessment and Data website, being there the link, and the financial data, the European Environment Agency website. As well, there is the link. Then I perform data analysis in each one of the factors to see how this behave during these years and how they impact or relate with the economic losses of the countries. For that, I did a maximum temperature. Here you can see the mean, where it's 32.55. Which being related with the maximum and minimum, we can see that the minimum was 30.2 and the maximum 40.5, being closer to the minimum value than the maximum value, meaning that more values will be scattered between this area. And as we can see with the standard deviation, that more values are related between the 31 degrees Celsius to the 35, more or less. And this is because the standard deviation is so high, we can see that the maximum temperatures were not really close or were really constant. So the standard deviation gives this value. The median, we can see that was the 33.75. And that's all for the maximum temperature. The minimum temperature, in the same hand, we can see that the mean was minus 6.42. And the minimum was minus 14.7 and the maximum was minus 1.7, meaning that the mean is almost between the both values, but more close to the higher side. Well, if you can call this hard, right? But you can see here in the histogram, we can see that the minus 14.7 was a special case. It was almost like a single case, meaning that this may be a cold front that the country has had that year in specific. We can see that here the standard deviation is smaller, meaning that the points are closer to each other, they have similar values. The histogram also shows that most of the values are scattered between the minus 6 and the minus 3.86 and somebody plus minus something. For the maximum rainfall, we can see that the mean was 34.7, the standard deviation being 10.92, meaning that the values are scattered. They are not close to each other. They don't have similar values. We can see that the minimum was 22 and the maximum was 70.4. For that, we can see that there's these cases where there are outliners between the standard values, but as well, the standard values are more dispersed between 30.06 and 38.1 period. This is due to this not being a constant values, this being affected by other climate phenomena and climate events like hurricanes, tornadoes, and other examples. For the wind speed, we can see that this case they are more close to each other. They're having a closer range between our minimum being 7.5 and our maximum being 11.1. This means that these values are in a really close range, meaning that even if we have a standard deviation 1.03, meaning that the values are really are scattered, we can see that they are not like really changing between each another, so maintaining a general formula. And as well, we can see this in the mean that is 9.27, meaning that this value, well, you can see the histogram is really close to each another. So this is a more of constant phenomena. As well, from sunshine hours, we can also see the mean is 14.86. Minimum and maximum, there are 13.4, 15.4, meaning that there are not a lot of changes between these. They are close range. And from the standard deviation, we can see that more of the values are close to the mean. As well, the histogram shows this, that the common is between 14.4 to 15.4, close, but more of the values are close to each another, and more values as well. They are higher values between the 15.4 or something, but they are not really changing, or so this value is really constant. But we also know that how this relate to the economic losses, because here's an analysis of the data, but next, I want to show you some scatter plots I realized to see how this relates to the economic losses. So we have these scatter plots that show us in the y-axis, the economic losses in billions that I mentioned before, and in the x-axis, each of the variables we're analyzing. To start the maximum temperature, we can see that the values are closer to the line, meaning that the R square is lower. But as well, we can see that it has some changes and some variations. They are not really all close, meaning that even if this variable could indicate that there will be an economic losses, that doesn't mean that it's really reliable as well. From the annual minimum temperature, we can see that these values are more scattered, more dispersed between the values. So the R square is high, meaning that is not a really reliable variable as well from maximum sunshine hours. These are so dispersed. This is not good to consider this as an only factor. We will need more sources and more data to say this is how economic losses behave with these variables. Animal maximum rainfall, we can see at the start that the values are really concentrated in the start, but then we can see that they start dispersing, meaning they are not really an indicator of an economic loss, as well as maximum wind speed. It has a similar behavior. We can see that the values start really condensing in one place, but then they start changing. Meaning, as well, the R square is high, meaning this is not a good indicator. But for my conclusion, I will see that even if they could indicate that there will be an economic losses, that is the use of data analysis to predict how some things and some things will change over the time. We cannot use that data to say that there will be an economic loss, how the economic losses will behave, because there is not enough. For example, maybe the maximum temperature was due to a drought, and that could affect the agronomical industry in France. That could be an indicator, but only that data, the maximum data, is not the maximum temperature is not enough. As well, from the minimum temperature, we can say that okay, it was a cold year, so maybe some industry was slow, but it's not enough. We need more data to see the context of each year, because we have some special cases in the years where economic losses were due to other things. So we have to see more data, more context to make a real accurate prediction about how economic losses will happen in the over the future years in France. That will be all for my part. Thank you for watching.